Good day. My name is Gabriel, and I am here to present my uh, project for the CS270 Advanced Database Systems. And the title of my project is Evaluating the Performance of Linear Regression Algorithms in an In-Database Machine Learning Environment. So with the explosion of data in terms of volume and variety, has pushed researchers and organizations to seek ways on how to manage and extract value more efficiently by pushing the limits of database and machine learning research. And one of the prominent areas in this domain is the in-database machine learning approach, where most of the machine learning calculations were brought closer to the database in order to reduce costs in moving data to specialized machine learning toolkits. So if you can see the diagram here provided by Cadent Nuggets, okay? So traditionally we have a regular database, which is the blue block at the bottom, and the application containing a business logic and the intelligence. And the database merely acts as the source of the data. Whereas in database machine learning, we push down the intelligence to the database together with the rest of the data, and the application becomes quote unquote thinner in some sense, okay, or lighter, since they will simply extract these results or insights from the database. So in this sense, we are leveraging on the physical resources of the databases, which are mostly designed for parallel processing and concurrency. So in terms of the architecture, this has been a challenge of the researchers, where they see that most of the analytics techniques, machine learning techniques, they would require different types of solvers. So they would need to have their own specialized codes and scripts or objects. Okay, so it's becoming more difficult for the database industry to have an architecture that can support all or most of them. So they see that the ideal architecture is something that could support as much existing code paths in the database as possible. So there were different approaches that was done before. So there were some researches that leverages on user-defined functions as the abstraction layer. Some of the approach research also leveraged on factorized joinings. Some of them also went into statistical relational learning that can support Markov chain analysis directly onto the database. And there are some commercially available in database machine learning systems that are tightly integrated into the entire database system or the relational database management system. And one of those is the SAP HANA database. Uh, to connect to that, just to give a brief description of what SAP HANA is. So SAP HANA is the database offering of SAP, and it's an in-memory database platform built for combined transactional and analytical processing. So with the advancements from the hardware and both hardware and software, okay, SAP HANA can support a lot of enterprise application requirements in terms of data collection and insight extraction. What makes SAP HANA, I would say, special is that this is a database that has native machine learning or predictive algorithms. So they contain native C++ algorithms, and which is called HANA Predictive Analytics Library or HANA PAL. And these libraries or these algorithms are accessible via the application functional library. Okay, so the reason why I mentioned this is because for this specific project, we chose SAP HANA as the main platform for the in-database machine learning approach. So in terms of the experiment design or the methodology, so our main objective here is to compare the performance of machine learning, which is executed in the database, to the one executed outside the database. And we are measuring them using the average elapsed time. So when it comes to the machine learning aspect, we simplify the scope of the project to simply looking at linear regression, And in this case, the linear regression is solved via the single value decomposition. Okay, so we made sure that both environments, the in database and out database, have the same algorithms implemented. Okay, when it comes to how things are measured in this experiment, so gathered we measured the average elapsed time from the point which the date where the data is accessed. Okay, and when the model is created, when we apply the model or predict do the prediction and write again the results back to the database. So we do not involve further transformations in between. So we assume that from the data access point, the data is already clean and ready for model creation. And in this case, we also did not explore splitting the data set into the test and train data sets, which is the standard way to conduct data analysis or machine learning. Okay, so we used the exact data source, the 100% of it, as the training set and also the test set. So since here we are not measuring the accuracy of the algorithms, we are simply measuring the performance. We deemed that we assume that these aspects that are related to improving accuracy and robustness of the model will be insignificant for this project. So we did this. We did measure the elapsed time over 10 iterations using 4 different table sizes. So we used a 25,000 row data. We used 50,000 row. We used 75,000, and we used the 100,000 rows of data. Okay, to simplify the process, so we provided a pseudo algorithm or algorithm shown on the screen at the right side. Okay, so on the left hand side, that is the CRISP DM or the cross industry standard process for data mining. Okay, and encircled there is the modeling phase. So just to emphasize that the focus of this project is specifically on the modeling part where predictive models are created. Okay, so in this case, we measured from the objectives, we want to measure 2 approaches, but we added another one, which is also part of the multi-tier approach, but it leverages on a specific Python library, which I will explain later on. But the 2 other approaches would be, of course, the in-database using the HANAPAL. Okay, and the second approach is the multi-tier approach, which leverages on the same HANA database as the data source and the Python via Jupyter Notebook as the client system. Okay, so within the HANA database, HANA database provides a UI for users to perform their data mining or their machine learning activity. So it's a drag and drop user interface called the HANA Flow Graph. So the HANA Flow Graph actually conceals the complexity or of manual scripting. So behind this, SAP HANA actually creates the SQL script that is actually executed by the database. So in this case, you can see the activities on each node, okay, and each link defines the data flow. Okay, so we have here the data source, which is located inside the HANA database. We are now calling the linear regression uh, uh, action or function that will actually create the model based on that data source. And then we will now apply the model onto the same data source. As I've mentioned earlier, we are not measuring the accuracy or robustness of the model, so we do not see that creating test or train data set separately would be necessary. We do not see it necessary. So we simply just apply the prediction onto the same data set, and then we join them onto the same table, and we write it back to SAP HANA database. So it follows the algorithm that was proposed on the previous slide. Now, for the multi-tier approach, basically what happens here is that we are connecting to the HANA database, we extract the data from that specific HANA table, okay, and then we copy it into a pandas data frame. So we do the model creation on the pandas data frame. So the creation of the model, the application, and the joining happens at the client system. And then we push it back to the HANA database to write it as a new table, okay, into the database. So this is the standard or the currently status quo approach. So as you can see here, we are actually duplicating our data from the database. So as we extract the data from the HANA table, we copy it into a pandas data frame, which is now situated onto the client system's memory. And then we just simply write it back into the HANA database. Now, the third approach, and this is actually interesting, so we added this into the experiment, is using still a multi-tier approach, but instead leveraging on the HANA Machine Learning API. So this HANA Machine Learning API is also provided by SAP for the Python lovers, Python users to be able to do in-database machine learning on a different interface. So comparing it with the in-database approach where they access directly the database and have that graphical user interface. In this case, they are using Python scripting, uh, but use leveraging on the library, on the HANA library. Okay, so we conducted the same approach. So we established a connection to the HANA database, and we are calling the HANA table, and even the training of the model, the prediction of the model, and creation of the table all happens still within the database. But instead, we are simply scripting the instructions on the Jupyter or Python layer. So what happens here is that all the codes here, okay, or all the functions that is used from the HANA ML API library are all SQL calls back to the HANA database. So here's here's the result of the entire experiment. So again, we used four sizes of the data of four data sizes, which is 25,000 rows, 50,000 rows, 75,000 rows, and 100,000 rows. And we have here the different uh, average elapsed time, okay, for each of the approaches and each of the data sizes. We've also provided two visualizations. One is on linear scale and the other is on logarithmic scale to show you the differences in terms of different fits. Okay, and as you can see here, the in database actually provides tremendous reduction in execution time. Okay, and by looking at the linear fit, okay, we can see that there's a 98.81% reduction in terms of the total or overall average response time. Okay, by simply looking at the scale of how the elapsed time grows together with the number of rows. Okay, we also measured the two other approaches, so the out database versus the DB API, okay, and we've seen an increase of 84.2%. Okay, this is assumed to be the effect of continuous sending of SQL commands to the database, okay, instead of providing a whole script to the database itself. So to explain it further, okay, going back to the user interface. So the HANA flow graph actually creates an entire SQL script behind that interface, and the all of those transactions, okay, all of those commands will be executed synchronously within the database, compared to using an API on Python, where each of those lines will send these instructions separately. So we can what we are assuming at this point is that continuous calling or multiple calls that happen when using the database API uh, contributed to the increase in average response time. Okay. However, there's still the benefits of having an in-database approach. All the data is still residing in the database. and we do not, which means that we're reducing our data footprint, and also we reduce the costs in data movement. Okay. Now, another area that we also uh, see worthwhile to explore is the overall experience of doing machine learning. Even though that we simplify the entire process, we believe that we covered most of the essentials. Okay, so we can explore four different areas in terms of the experiment of the experience. First is the development environment. So in terms of the development environment, good for SAP HANA to provide a visual or a user interface. Compared to other commercially available databases, they most likely are using the SQL scripting. Okay, but this SQL scripting is also available in SAP HANA, so that for those who are keen to use SQL commands, they can still perform in database in database machine learning. But the beauty of having this user interface, this HANA flow graph, is for people who are just starting on their in database machine learning journey. So they can leverage on these interface so that they could extract insights as soon as possible without while they are still learning the scripting side. Okay. However, okay, again, for other databases that which are not SAP HANA, which may not provide this user interface, uh, people, data scientists or those who are trained to become data scientists, mostly they are using Python or R script or R language. Okay, and this they might prefer the Python environment over uh, performing things on SQL scripts. Okay, so one uh that is one of the areas that where doing out database approach would be more beneficial for the users. Okay, so they would be able to extract insights more quickly when you do performing out database than using in database if their option are merely SQL scripting. Now, in terms of the SQL scripting, so we're also covering the programming language aspect here. Uh, this could appeal to data engineers or database engineers who want to expand their domains or expand their skill set to data science. Okay, so because these people, okay, the data engineers, database engineers who are really well versed on the script on SQL scripting, they may now use the same skills to uh, to perform data science activities. So it's more of just an augmentation of their current skill set rather than learning a new language like Python or R. Okay. Now, with the differences of manual scripting and user interface, that could also spell the difference bit on the debugging experience. So personally, when we conducted the experiment, it was a bit difficult to navigate and perform debugging on a user interface uh, on on a graphical user interface. So we have to explore other windows. We have to rely back to SQL scripting just to identify what errors are we experiencing compared to like when you are doing manual scripting, such as a Python script on the right. Okay, so some of the environments like Jupyter or other IDEs. Okay, they can actually help you on the debugging aspect, so they could run each line one by one and see at which point of the code breaks in the process. Okay, so that could also define the success of the adoption of in database machine learning. Okay, and lastly, with the documentation support and community. So in this case, since we use SAP HANA and it's still a proprietary technology, so the community are mostly around the SAP community. Whereas when we look at Python community or our community, they have more support. They have more open source scripts, okay, that can be leveraged basically anybody. Okay, so there would be a much wider support uh, compared to proprietary technology communities. Okay, so these four areas, which we believe could define the overall success of the adoption of in database machine learning. So, to summarize or to conclude, so why would we want to push for in database machine learning is because again we want to reduce the costs of moving the data. So by moving the calculations closer to the database, basically there's technically no data movement at all. Okay, plus the performance benefits of running it on a hardware dedicated for multiple database transactions. This could help uh, this could provide faster deployment of predictive models. Okay, so when we say deployment, this means even putting these models into production, into actual use of applications, it will be made much faster compared to doing these machine learning outside the database. And another benefit of doing in database machine learning is also for uh, skills development of data engineers or database engineers who would want to expand to data science. Now, from this simple project, okay, there are still a lot of areas that can be improved and or probably for which can be done for further research. Okay, one is of course we used SAP HANA in this experiment, and as using SAP HANA, it's just one among the in database machine learning architectures that was presented. So it would also be better to explore the performance of other architecture, okay, of in database machine learning systems by using other databases, open source or commercially available. And since here we just used one uh, machine learning approach, which is the linear regression, exploring of other machine learning scenarios could also be an area of future of further research. So other we may also want to look at classification, neural networks within a database and see if the same observation uh, is evident, okay, to see if there are still performance benefits of doing it in database. So that is just a quick presentation about the project on the in database machine learning, and I hope you got something out of this presentation. Again, my name is Gabriel, and I hope you have a good day. Thank you.